Okay. All right, so this is where we left off. It's got the definition of a spherical coordinate system, and you can see the theorem 2.16 that we're going to use. It shows us our conversions, where we have rho, theta, and phi, however you want to say it. And then we have our statements here that we're going to end up using quite a lot. So you'll definitely want to write these ones down. Uh, so what we're going to do is we're going to use our conversions here to do some examples. And I'll wait for the last two students to join. We can write those down. I can try to make them a little bit bigger for you. Ah, I don't know if that helps. All right. So the next slide just shows again how they're bringing that kind of from the rectangular to the spherical, or yeah, spherical, not cylindrical. Okay, so that stuff you can get later if you want to either screenshot it and print it out, or if you want to try to draw that, more power to you. That's why I stole it. All right, so let's do an example. So they want us to convert from spherical coordinates. It says plot the point with the spherical coordinates 8, pi over 3, and pi over 6, and express its location in both rectangular and cylindrical coordinates. So we'll do the spherical first, and then we'll do the cylindrical. So now is that we need to find x, y, and z, and we're given rho, theta, and phi. My Greek letters are very bad, so I apologize. So we're going to just do our best with my So then if we replace in, we're gonna have 8 sine pi over 6 cosine pi over 3. And if you work that out, that ends up being 8 times 1/2 times 1/2. 1 second. So that's the same as 8 times 1/4, which is going to give us a 2. So x is going to be 2, y 0 sine b cosine, nope, sine theta. All right, you guys try to fill that in while I let the last person in. Okay. All right, so then for this one, we would have 8 sine pi over 6 sine pi over 3, which would be 8 1/2 times the cubed root of 2, which would give us y equals 2 cubed root of 3. And then z rho cosine b is 8 cosine pi over 6, which is 8, which then is 4 cubed root of 3. So your spherical coordinates give us rectangular coordinates. So our rectangular are 2, 2 root 3, and 4 root 3. So that's the first part. The second thing they wanted us to find was the cylindrical coordinates. So that's given as r equals sine phi, which is 8 sine pi over 6, which is 8 times 1/2, which is 4. Theta is equal to theta, so that part's not going to change. It's just going to be pi over 3. And z we just did. Z stays the same. So then we would have cylindrical of 4 pi over 3 okay. All right, so that's all the hard work, and then this is what it would look like. So I imagine your exams are not fully going to be paper and pencil. So if there are graphing options like ABC style or multiple choice, pick the one that matches your actual work. I'm not going to be super picky on your drawings. If you draw something that looks like that and you label it correctly and you have the orientation right, I'm probably going to give you most of the points. If you have the orientation flipped, but you have everything labeled correctly, I will probably take some points off. I think drawing that by hand will be very impressive, so I will treat you in kind with that. Okay. All right, so the second one says convert the coordinates -1, 1, and the root of 6 to both spherical and cylindrical. So I'm actually going to give you guys the formulas. Let's go back. Okay. I'm going to give you guys the formulas you might need for this and see if you guys can work it out. So here's what we know. Okay, so X, Y, and Z. So we have to figure this out first. So rho -1 squared plus squared plus the square root of 6 squared. So that's going to give us 1 plus 1 plus 6, 8. Yes. Which means that was a squared. That's what I dropped. Now we have to find the square root of both sides. So then just that would be 2 square root of 2. Okay. And then we have to use tangent theta is equal to y over x. So that's 1 over -1. So then theta equals the arctangent of -1, which is 3 pi over 4. And then there are actually two ways to identify B. We can either use an arc cosine, or there's a simpler approach. So I recommend using it. So I will write in red your harder option if you want to challenge yourselves. Okay. But we're going to use the easier option. So we're going to do Z equal to what we just found. If you guys have found a cool, neat way to write that, I applaud you. I feel like I write it differently every time, so hopefully you guys know what I mean. So let's plug that in. We know that Z is equal to square root of 6. And then we just found 2 square root of 2. So then we have cosine, which is 6 square root of 2, which is going to work out to that. So then we end up finding, we would have to find cosine inverse, which is going to give us pi over 6. Okay, so if we put all that together, okay, and then for the cylindrical, we only have to find r. We know everything else already, right? Because we know theta and we know, where's the other portion? Z. So, guess we haven't used black yet. So r sine and if you work all that out, r is equal to the square root of 2. So then our cylindrical, did I spell that wrong? No, I didn't. I spelled it right. Coordinates are going to be square root of 2, 3 pi over 4, and square root of 6. Okay. Is everyone able to follow along with all of that? Should be pretty good, right? Cool. Right. So 9 is a bit long. You can see that there's 4 different parts. I did spread it out, so we have a little bit of room to work with stuff. So it says that we need to describe the surfaces with the given spherical equations. So the first one is theta equal to pi over 3. The variable theta represents the measure of the same angle in both cylindrical and spherical coordinate systems. So we would end up having so that would be part of our known. And then we know that the plane that forms an angle of pi over 3 with the positive x-axis, so that tells us that rho has to be greater than 0. The surface described by the equation is a half plane. And I will show you what it looks like now. Okay. So hopefully you'll be able to handle something like that on your own when you have homework. All right, the next one says that we have phi of 5 pi over 6. So This describes all points in a spherical coordinate system that lie on a line from the origin, forming an angle measuring 5 pi over 6 radians with the positive z-axis. These points form a half cone. So it's from the origin forming angle 5 pi over 6 with the positive z-axis. All right, and I'll show you what that looks like. Yeah. Some pretty neat stuff. Obviously, they use some computer generated drawings. Your stuff, I promise you, I am not an artist, so I'm not going to ding anybody on how you draw that. So again, to find the rectangular coordinates here, you would want to use, and I don't have the room to do it, so you guys can try that on your own. I think you'll be fine. Okay. And I believe it works out to, I can also give you the what it works out to so you guys can make sure you can find the missing parts. Oops. So plug everything in and you should end up with that. And that would help you towards what you're looking for, which is this ultimately. Okay. All right. The next part I think I did. I brought over the equations. So part C, we're looking for rho equal to 6. So this describes the set of all points 6 units away from the origin, a sphere with radius 6. This is a sphere. Okay, so let's see what that looks like. There you go. Oh, I don't think I had a picture for D. That's why I had all this room. That makes more sense. Wondered why it was all here like that. One second. I'll just rewrite it. It went away. All good. This is a sphere. Okay. So part D, we're looking at, and it says rho is equal to sine theta sine phi. So to identify this surface, convert the equations from spherical to rectangular coordinates using, use y equals So here's the first thing we know. So we know this. Okay, so what we'll do is we'll then multiply both sides by a rho. So we would get rho squared equals rho sine theta sine p. God, I hate writing that. So we're gonna then substitute the rectangular variables into the equation. So on the right side, so we would have x squared plus y squared plus c squared equals rho sine theta sine phi. Actually, that is y. Apologies. Okay. So then we're gonna subtract y on both sides. And then we have to complete the square. So we would have x squared plus y squared minus y plus 1/4 plus c squared equals 1/4. So then we would have x squared plus y minus 1/2 squared plus c squared equals 1/4. Okay, so the equation describes a sphere centered at 0.0150 with a radius of 1/2. So, sphere with radius 1/2. This is part D. Yep. All right, that part was a lot of writing. All right. Okay, so this is one of our application problems. Converting latitude and longitude to spherical coordinates. The latitude of Columbus, Ohio is 40 degrees north and the longitude is 83 degrees west, which means that Columbus is 40 degrees north of the equator. Imagine a ray from the center of Earth through Columbus and a ray from the center of Earth through the equator directly south of Columbus. The measure of the angle formed by the rays in 40 degrees in the same way measuring the prime meridian, Columbus lies 83 degrees to the west. Express the location of Columbus in spherical coordinates. Okay, so the first thing you need to recall is that the radius of the Earth is 4,000 miles. So that means that rho will be 4,000 miles technically. But let's just do we'll do the units over here. So that's where we get that. And the intersection of the prime meridian and the equator lies on the positive x-axis. Movement to the west is then described with negative angle measurements, which shows that theta would be equal to negative 83 degrees. Because Columbus lies 40 degrees north, it lies 50 degrees south of the North Pole. So that's going to be 50 degrees. So that gives us spherical Okay, so you have to use the directionals that they give you. So that's going to help you figure stuff out. So let's pull some stuff out of here. So if you have a similar problem, you know what to do. So west is going to be negative. And then 40 degrees north. North means that you have to subtract from 90 degrees to have okay. So just some things that'll hopefully help you out with your answers there. All right. So 12 looks like it's really big. Okay. So we'll probably talk about this more than just having me throw a bunch of paragraphs at you. So it says, in each of the following situations, we determine which coordinate system is appropriate and describe how we would orientate the coordinates axes. There could be more than one right answer. And for how the axes should be orientated, but we select an orientation that makes sense in the context of the problem. Note, there is enough information to solve or to set up or solve these problems. We simply select the coordinate system. Okay, so you're not going to be able to do anything too much more than figure out what kind of system you would use. So for A, it says find the center of gravity of a bowling ball. So we obviously know that a bowling ball is what? A bowling ball is what? It is a ball, therefore it is a sphere. So we would go with, yes, a spherical coordinate system. Okay, very good job. So there's no obvious choice for how the axes should be orientated. I mean, even like your most avid bowler is not going to sit there and go, well, we could put it directly in the middle, or we put like it really doesn't matter. So that's your answer for that one. So for B, it says determine the velocity of a submarine subjected to an ocean current. So a submarine typically is going to move in a straight line. It's a rather big piece of equipment, so you're not really going to be doing too much with it. It can't do a whole lot of things. So there is no rotational or spherical symmetry that applies to this situation. So the only option really here is going to be rectangular. And I don't believe that it's saying like because it could be spherical, they mean like what you're actually doing with it. So rectangular coordinates are going to be best there. The z-axis should probably point upwards. The x and y axes could be aligned to point east and north respectively. The origin should be some convenient physical location, such as the starting position of the submarine or the location of a particular port. I mean, but you could also argue that the origin could be, I don't know, the door, because you walk through the door to get into the submarine. So the main parts are that the z-axis must be, what did I just say? Upward, probably upward. I mean, you probably don't want your sailors to be conked on the head by flipping it upside down. And then X and Y, they say they go with east and north, so that's fine. Okay. Next, we want to calculate the pressure in a conical water tank. That is the saddest picture they could have given us for a water tank. That, ladies and gentlemen, is a straight up cone. It is just a cone. That is not a water tank whatsoever. That is just sad. Okay, so ironically, even though you all see that question C says calculate the pressure in a conical water tank, right? We can all read that that's what that says. Yes. All right. Let me just start reading to you what the answer is here. A cone has several kinds of symmetry. A cone, as in what is pictured, not what was asked of us. So cylindrical coordinates, a cone can be represented by z equals kr, where k is constant. In spherical coordinates, we have seen surfaces formed by phi equals c are half cones. And lastly, in rectangular coordinates, elliptical cones are formed by z squared equals x squared over a squared plus y squared over b squared. So honestly, it could be any of them. Um, so, I don't know. That is just a very dumb thing there that they could have just actually given us what they wanted. Anyway, part D says find the volume of oil flowing through a pipeline. They went back to matching with their picture. So a pipeline is, of course, going to be cylindrical. So we're going to go with the cylindrical coordinate system. And in this case, however, we would likely choose to orientate our z-axis with the center axis of the pipeline. So z-axis is equal to the center axis of don't know what two letters that was, of the pipeline. So the x-axis could be chosen to point straight downward or another logical direction. The origin should be chosen based on the problem statement. Note that this puts the x-axis in a horizontal orientation, which is a little different from what we usually do. It makes the most sense to choose an unusual orientation for the axes if it makes sense for the problem. So the only other thing they gave us was that the x-axis, what do they want us to do with that again? X-axis. Oh, chosen to point straight down. X-axis straight down. Because of that, this could be horizontal. So just know in the back of your minds that that's okay because it goes with the situation. So the last one says determine the amount of leather required to make a football. A football has a rotational symmetry about the central axis, so the best option here is again going to be cylindrical. Would work the best. The z-axis would align with the axis of the ball. The origin could be the center of the ball or perhaps one of the ends, and then the position of the x-axis is arbitrary. So okay. Sorry. I'm fair warning all of you guys. I know this is on recording, so I guess I'm fair warning whoever should possibly watch this in the future. While we switch gears to get to chapter 3, I get horrendous allergies. Like you'll probably think that I'm dying, and I won't argue you. Um, they're they're ridiculously bad. So, I still function. I just will sound awful. I do take medication, so I guess don't feel too bad. It just it's when I don't take medicine, I sound literally like The Walking Dead. Like there's nothing I should be doing if I'm not taking medicine. And I'm a huge baby about it because I forget sometimes that I have seasonal allergies. Because you know the seasons take a while here. Well, in Florida they take a certain while, but um, yeah. So you'll have to bear with me as I can't breathe, probably for a good portion of the rest of the semester. But anyway, I do have another. Someone try to remind me. I do have another announcement, but I don't need to make it right this second. You can see that we have a very short 3.1. It's oops, not mean to write on that. It is only 8 slides. We are going to be talking about vector valued functions and space curves. Surprisingly, we get all that in only 8 slides. So please make sure that you read your textbook if you want further details. Or if you need further details. So, definition, a vector valued function is a function of the following form. We would have r of t equals f of t times I plus g of t times j, or you could throw in the k as well, or the h of t and k. Where the component functions f, g, and h are real valued functions of the parameter t. Vector valued functions are also written in the following form, and you can see that that's with the vectors there. In both cases, the first form of the function defines a two-dimensional vector valued function. The second form describes a three-dimensional vector valued function. Okay, so if you're someone who likes to take down notes, you can take those down, but I'm sure we're going to be rewriting them more than likely. But again, if you want to take them down, go for it. I don't know if any of you suffer from allergies, but I take the only allergy pill that works for me is Allegra, so I have to take it every 12 hours, and I cannot take it now because I do not see 6:15 in the morning. So 7:30 is the latest I can do it, or earliest I can take it. All right. Evaluating vector valued functions in determining domains. For each of the following vector valued functions, we want to evaluate for r of 0, r of pi of 2, and r of 2 pi over 3. Do any of these functions have domain restrictions? Okay, so we have to answer all of those questions. So let's start with A. And I think, no, I did try to squeeze this on both. Okay, or both of them on here. All right. So we might have to put in another, another slide potentially, because I didn't know these each had parts. But we'll try. All right, so the first one is r of 0 is going to be 4 cosine 0 I plus 3 sine 0 j. So that would give us 4i plus 0j, which is just 4i. Okay, then we want to do r of pi over 2. So that's 4 cosine pi over 2 I plus 3 sine pi over 2 j. And if you work that out, you're going to end up with 0i plus 3j. So that's just going to be 3j. All right, and then the last one is 2 pi over 3. Also, I should point out to you that I am writing on a tablet, which I think I've announced before, but you'll notice that I am writing currently very, very sloppy. Please don't do as I do. It's very hard to write on a tablet neatly. Make sure that I can read what you're writing so that I can give you as many points as possible. That is ideal. Okay. So that is all for part A. To determine whether the function has any domain restrictions, consider the component functions separately. The first component function is going to be f of t, 4 cosine of t. And the second component function is g of t, 3 sine of t. Neither of these functions has domain restrictions, so the domain of r of t with everything is going to be all real numbers. So domain is all real numbers. Right. So we have to do the same thing for part B. So r of 0 is going to be 3 tangent of 0 I plus 4 secant of 0j plus 5 times 0k. And if we work that out, we get 0i plus 4j plus 0k. So that's just going to be 4j. All right, then we have r of pi over 2. So 3 tangent pi over 2i plus 4 secant pi over 2j plus 5 pi over 2k. That's going to work us out to get it does not exist. Okay, so then the next part is r. Darn it, I did it again. 2 pi over 3. So that'll be 3 tangent 2 pi over 3i plus 4 secant 2 pi over 3j plus 5 2 pi over 3k. And that is going to work out to be 3 times negative q, or square root of 3i plus 4 minus 2j plus 10 pi over 3k. And then if you work all that out, you would get negative 3 square root of 3i minus 8j plus your 10 pi over 3k. All right, and then your domain for this one, let's talk about it. To determine whether this function has a domain restriction, we would look at the following separately. So 3 tangent of t, 4 secant of t, and 5t. The first two functions are not defined for odd multiples of pi over 2. So the function is not defined for odd multiples of pi over 2. So therefore, our domain here would be t such that t is not equal to 2n plus 1 pi over 2. Where n is an integer. Where n is an integer. Okay, so you have to have both of those. I don't care how you write it out. You can just give me the domain, and if you're right, you're right. You can work it out for me, at least in the sense of saying f of t equals 3 tangent t. That domain is function is not defined for odd multiples of pi over 2. G of t is equal to 4 secant of t. Same thing, the function is not defined for odd multiples of pi over 2. And then h of t is all real numbers. So if you give me a little bit more and not just the domain, then I can give you more points. Or I can have an understanding of what you're doing. Okay. So the next example is talking about graphing a vector valued function. I do believe these go on to the next slides. It says for part A here, the plane curve represented by r of t, and it's 4 cosine ti plus 3 sine of tj, and then t has to fall between 0 and 2 pi. So I actually gave you this table mainly because I didn't feel like I would be able to nicely write it on here. So really what you would have seen, or what you would have done, is you wouldn't have known these items yet. You would have to figure all these out. Okay, and you would figure them out, obviously, by plugging them into your formula. 4 cosine t I plus 3 sine t j. And you can see here that your t's are the values that were given. So once you would have those answers worked out, you would then be able to determine your graph. Okay, so that should kind of take you back to some algebra stuff. Yeah, you're working with bigger items and, you know, having to do some extra stuff with it. But at the end of the day, that should come back to your kind of how you would do algebra. So I'm hoping that you can see this without me having to go through step by step. And I think that's okay. Right? Okay, so we did the same thing here. So again, you would have your R of t here is 4 cosine t I plus 3 sine t j. How are those different? Okay. Okay. My allergies must really be getting to me. I'm not seeing anybody else seeing how these two parts are different. We obviously have two different. The graph of the first vectored valued function is an ellipse. The graph of the second valued function is also an ellipse. Ah, but it's not up top, right? So I wasn't crazy. They're using a separate, okay. All right. Nice. Good catch. My brain was about to break. All right. So typo is here. Okay. Well, that makes me feel much better. Okay, so 2t I plus 3 sine 2t j. Excellent. Nice catch. All right. Good deal. You guys are rolling with it. That's one of those moments where you're like, nice job, publication company, that's called, not doing their editing too well. Okay, so this one is 4. I'm gonna look at the bottom now, even though I think they do match. 4 sine e j plus t. Okay. All right. And then you guys can see this fun little spiral. It's actually a helix, but they remind me of slinkies. I don't know about you guys, but that's what they remind me of. So definitely, I recommend if you don't know where they're getting the inside portions of the tables, if you're not seeing how they're getting that, then go through and practice these ones because you already know the answers to them. And make sure that you follow that the whole way through. Okay. All right. The values then repeat themselves except for the fact that the coefficient of k is always increasing. This curve is called a helix. Notice that the k component is eliminated. Then the function becomes cosine ti plus sine tj, which is a unit circle centered at the origin. All right. We're almost done for a week. Okay. So definition, a vector valued function R approaches the limit L as t approaches A when, and it gives you the definition there for the limit, provided that the limit of the absolute value is equal to 0. Okay, and then it also has a theorem. So the limit of a vector valued function, let f, g, and h be functions of t, then the limit of the vector valued function as t approaches a is given by the following limit. Okay, and you can see that you can expand those limits as you need to given your function. Okay, so since I don't have any wonderful faces on right now, just somebody give me a thumbs up when those of you who write your notes are good to go. If you don't write your notes, don't be rude and put a thumbs up yet. Okay. All right. Thank you, Tiffany. Okay. So this is our last example. There is obviously some notes, so don't go running. And I do have a class announcement for after the recording's off. So stay with me. Don't leave just yet. I think that's okay given how much time I let you guys have all the time. All right, so evaluating the limit of a vector valued function. For each of the following vector valued functions, calculate the limit of R of t as t approaches 3 for the following problems. So for part A, we're going to have the limit as t approaches 3 for t squared minus 3t plus 4i plus 4t plus 3j. So if we want, we can split those up a little bit. We can do the limit as t approaches 3, t squared minus 3t plus 4i, and then we can also do the limit as t approaches 3, 4t plus 3j. Okay, so for the first set, we know that that limit is going to be 4i, and the second limit will end up being 15j. If you need to go over your limits, there are amazing YouTube videos out there. Of course, you guys already know my recommendations for YouTube videos. So. Right, and then the second one, we're going to do the same thing, the limit as t approaches 3. It's going to be for 2t minus 4 over t plus 1 I plus t over t squared plus 1 J, I need more room. Plus 4t minus 3. Okay. All right. So again, we can split our guys up. I guess if you wanted to, you could have put these in brackets if you wanted to be most correct. So put these guys in a bracket. The limit t approaches 3. If you guys don't need the extra step, you don't need to do the extra step. I'm not going to take any points off of anyone for being able to know how to do their stuff without the extra steps. However, if you need them, if they help keep you organized, then don't feel bad doing them. Oops. I had to go outside. Okay, I'm just gonna write this one down here. Sorry, guys. I just have no way to make the room work. So then, if you work all that stuff out, you end up getting 1/2 I plus 3/10 J plus 9 K. Right? Not too terrible. I will probably put videos up over the weekend. Maybe tomorrow if I get to them. I have been keeping up with the PDFs, so you should be able to get those if you need them. If you need anything and it's not on there, just let me know and I will get to it, or I will get it on there. All right, I'm going to stop the recording.